In this example, we have 125 c to the 6th minus 1/8 d cubed. So I don't think there's a GCF in this one. So, but which formula does it kind of resemble? The sum or the difference of two cubes? Kind of resembles the difference, right? Well, hopefully you're writing it down along with me in your notes, because if you're not taking notes, you're not getting as much out of the lecture as you could. Because if you're writing, you're getting the muscle memory of writing it down if you're writing the notes along with me, especially the formulas. So again, I know it seems boring, but write it down. A cubed minus b cubed. Factors to be the quantity a minus b times the quantity a squared plus ab plus b squared. Write it down every time you use it until you have it, until you can picture it in your head. Okay, you guys, what's acting like a in this case?
125c to the 6.
Oh, is it 125 though? So let me back off what I just did. Let's underline this guy. So this guy has got to be a cubed. Hopefully everybody realizes that. 125c to the 6 has got to be a cubed. And then b cubed, don't include the minus. The minus is built into the formula. B cubed is 1/8 d cubed. Just make sure you can see that, right? And then, so what's a have to be if a cubed is 125c to the 6? Ooh, that's a tough one. Well, let's think about it. I mean, right now you're tempted to say c to the 6. Maybe that's not a perfect cube. But it is. What could you cube to get c to the 6th? Well, you're right. With the 5, yeah, you guys are saying, so for the first part, 5 is going to be one factor of a. But what about the part involving the power of c? So you have to ask yourself, what can I cube to get c to the 6th? What can I multiply times itself 3 times to get c to the 6th?
C squared.
C squared. That's right. So let me tell you a trick to where you don't have to think about it too hard. Okay, remember from last time, any base brought to an even power is a perfect square? Right, we talked about that last time. So timeout. This has nothing to do with this problem, but let's make sure you see the connection here. So you know that x squared is a perfect square, right? If you take what we can call the square root of it. You guys have seen this symbolism before. The square root of x squared is x, as long as x is non-negative. We'll talk about that later on. You also saw that x to the 4th is a perfect square. What's the square root of x to the 4th? X squared. You also saw that if you were here, x to the 6th is a perfect square. What's the square root of x to the 6th? What's the number you would square to get x to the 6th? X cubed. Right? Let me do one more. X to the 8th is a perfect square. So my claim is any even power of any base, in this case I'm using x, but any base will work. Any even power is a perfect square. So what's the square root then of x to the 8th going to be? X to the 4th. So what's the pattern? What do you do? So you could think of this as x to the 1. What do you do to the exponent over here to figure out what its square root is? You divide it by 2. You keep the base, in this case x, and divide it by 2 if you want the square root. In other words, when I talk about square root, I'm just saying if you have x to the 8th and a difference of 2 squares factoring problem, then you would get the number you square to get x to the 8th, that's called the square root of x to the 8th, by just dividing that exponent by 2 and making that your new exponent on the base, x. Does everybody see that pattern? Let's do the same thing for perfect cubes. Let me set it up like this. Over on the right side will be the square root of the input on the left side. Cubed root, actually. Okay, so if you have x cubed, the cubed root would be the quantity you could cube to get x cubed. So what would the cubed root of x cubed be? What number do you cube to get x cubed? X. Okay. I'm leaving off the cubed root because it's built into the table right here. Okay? Okay, my claim is any power of x that's a multiple of 3 is going to be a perfect cube. So the next one up is x to the 6th. So think about it. What's the cubed root of x to the 6th? Put another way, what could you take to the 3rd power to get x to the 6th? It would be x squared. And the reason is if you take x squared times itself 3 times, remember you keep the base and add the exponents together. 2 plus 2 plus 2 is 6. So let's see if we see a pattern here. Okay, what's the next exponent up that has a multiple of 3 in it? What's the next number up from 6 that's a multiple of 3? 9. So what do you think the cubed root of x to the 9 would be? That's right, 3. Because if you took x cubed times x cubed times x cubed, you'd get x to the 3 plus 3 plus 3, x to the 9. One more. X to the 12th, if you had to guess, what would the cubed root of x to the 12th be? X to the 4th, for the same reasoning. Because if you multiplied x to the 4th times itself 3 times, x to the 4th times x to the 4th times x to the 4th, you get x to the 12th. So what's the pattern here to go from something that's a perfect cube to its cubed root, the number you would cube to get that something? What do you do to the exponent? Does everybody see the pattern? So divide this exponent by 3, you get the exponent that doesn't show up, 1. Divide this one by 3, you get 2. So you get the cubed root of x to the 6th is x squared. The cubed root of x to the 9th is x cubed. This is powerful, you guys. So if you just want to take the cubed root of some base brought to some exponent, as long as that exponent's a multiple of 3, then it's gonna that number is going to be a perfect cube, and the cubed root is just going to be the base to that original exponent divided by 3. Okay, now back to this problem. So we said, okay, 125 c to the 6th is our perfect cube. To get a, you'd find the number you would cube to get 125 c to the 6th. And that is the cubed root of 125 c to the 6th. So it's 5 because 5 cubed, 5 times 5 times 5 is 125, times c squared because c squared cubed is c to the 6th. Does that make sense? So I'm saying if you took 5c squared times itself 3 times, you would get 125 c to the 6th. Does everybody buy that? Okay. Now, so by the way, what's the shortcut then? Well, you know how to find essentially the cubed root of 125, the number you cube to get 125. That's one of your perfect cubes, right? 125 is, and it's 5 cubed. So 5 is the base of that. Now, the trick on the c to the 6th then, getting the base c and the appropriate power, is just dividing that 6 by 3, making it c squared, and then in front the 5, and you've got your a. Okay? Okay, so I know that sounds complicated, but believe me, it gets pretty systematic after you do it a few times. Okay, if b cubed is 1/8 d cubed, what's the number you could cube to get that 1/8 d cubed? What is the cubed root of 1/8 d cubed, in other words? Okay, 1/2 cubed would be 1/8, and then times d, right? You got to have that a factor of d in there. Does everybody agree with those? Any issues here? Does it make sense? Okay, that's most of the ball game, folks, because if you just plug in then to that formula in red for a cubed minus b cubed on the right side, you're good to go. So you plug in for this guy. What's a minus b? Well, you just look. What's a? What's b? And you subtract one from the other. Okay, so what's that going to be? What's a minus b?
5c squared minus 1/2 d.
Good. Okay. And then this second formula, okay, this first guy right here, a squared. So you're going to square a. A is 5c squared, so you're going to square that. So if you wanted to show some work on that, you could just take 5c squared, the whole thing squared, or you could do it all in your head if you can do that. That's more power to you. And then plus a times b, what's that going to be? So plus the a times the b, what's that going to be? Well, let's stick, here's the deal in this class. If you start out with fractions or whole numbers, stick with them, okay?
5 over 2 c squared d.
Okay, so what he's saying is we're going to take 5c squared times 1/2 d, but we'll regroup the multiplication and make it 5 times a half, but that's 5 halves, right? Multiply straight, think of it as 5 over 1, multiply straight across, and then c squared d. Is everybody okay with that middle term, where the 5 halves comes from? Okay, and then plus b squared. So I'll show the step on this. B is this guy. So I'll just make it 1/2 d and then square it, and then close that last parenthesis. Okay, so that's an intermediate step you don't have to show if you're good at multiplying these things out. I don't care if you show that step. So you do need to clean it up, though, if you do show that step. So that first factor is good, 5c squared minus 1/2 d. And then what's 5c squared? Notice the parentheses are around the whole thing, and then the whole thing is brought to the second power. What's 5c squared? The whole thing squared.
25c to the 4th.
25c to the 4th. You could just break up that exponent of 2 over multiplication, make it 5 squared times c squared squared, or c squared times c squared, which is c to the 4th. Okay, the middle term's good. 5 halves, c squared d. And this last guy, what's 1/2 d, the whole thing squared?
1/4 d squared.
Yeah, you got to square. Another way to think of it is just take 1/2 d times itself. 1/2 d, you get 1/4 d squared. And that's it.